Hi, in today's lesson, we're going to be going over multiplying monomials. Okay, very easy and simple lesson. So look at an example where we're multiplying monomials when the bases are different. So here we have 3x times 9y, and you know that when given this type of problem, you can multiply the 3 and the 9, right? 3 times 9 is 27. But you can't really do anything with x and y. So when we multiply them, what happens is they just get smushed together. So 3x times 9y is just going to give you 27xy. Okay. So the situation changes when the bases are the same. Okay. So when we multiply monomials where the bases are the same, something called the products of powers rule applies. And this is an incredibly simple rule and also useful rule. And what it is you have here a to the mth power times a to the nth power, where both m and n are positive integers. Well, in that situation, all you have to do is keep the base and add the exponents. Okay? Keep the base, add the exponents. So here we have an example. 2 squared times 2 to the third power. Well, this makes sense. So the this rule, a to the m times a to the nth, where you simply add the exponents, makes sense when you look at this example. So 2 to the second power times 2 to the third power. Okay. What is 2 to the second power? It's just 2 times 2. What is 2 to the third power? Well, that's 2 times 2 times 2, right? There's 3 2's and then there's 2 2's. And then you multiply them together. And what is that? Well, it's 2 to the fifth power. So that comes from adding the exponents 2 plus 3. And that's literally all there is to it. All right, let's go over some examples. So here we have x to the fourth times x to the fifth. So since their bases are the same, you simply add the exponents. 4 plus 5 is 9. Example B, same thing. C to the seventh times c to the third is going to be c to the 10th, right? Because 7 plus 3 is 10. And x times here we have x to the third times y to the third. In this case, the base isn't the same. Therefore, the only thing you can really do is put them together like that. Okay. All right. Let's try another one. So here it says to simplify. And as we've done in previous examples, all you have to do is multiply the coefficients together and then the variables. So separately, what's happening here is 2 times 3 times a squared times a to the fifth. All right, so 2 times 3 is 6. And since the bases here are the same, right, both have bases equal to a, you just simply add the exponents. 2 plus 5 is 7. So this is going to be 6 times a to the seventh power. Okay, let's try another one. So same deal. You're multiplying your coefficients, right? Your integer coefficients together, -3 times 5 times x. So this one's a little different, but the idea is still the same. So since the base for the x's are the same, you just simply have to add the exponents. So here we have a 3, and here you have a 1. Okay, 3 plus 1 is 4. So that's the same thing as same thing as x to the fourth, and then y. Okay, the bases are the same, so you just add the exponents. 2 plus 4 is 6. And when you put it all together, you get -15 x to the fourth, y to the sixth. Okay, let's try another example. Again, so the thing with fractions is you can use cross simplification. So here we have two. So just my recommendation is to separate out the integer coefficients from your variables So it makes multiplying easier. So here you have 20 over 3 times 15 over 5. And you know that given this type of situation, you can cross simplify. So 5 goes into 5 once, 5 goes into 24 times, 3 goes into 3 once, and goes into 15 5 times. So you can just multiply across. 4 times 5 is 20 over 1, which is the same thing as 20. Okay, just set that aside for now and work on your variables. So since the variables are on top, in other words, they're the numerators, you don't have to worry about making them into a fraction or anything. So this is the same thing as x to the third, y to the second times x to the fourth, and y. Okay, so the bases are the same, x, y, and xy. So what you're gonna end up with is x to the seventh, right? 3 plus 4 is 7. And then 2 plus 1 is 3. And then at the end, you can just combine it, right? Don't forget that you have this 20. So you have 20 and then x to the seventh and y to the third power. And that's going to be your answer. All right, let's see how many. Last example. Okay, again, the idea is the same. It just looks slightly more complicated. So we're going to simplify that and we're going to simplify that part and then add add them together. Okay. So 5 times negative 5, what is that? It's negative 25. And then we have our x. 4 plus 2 is 6. And then we have our y. 6 plus 1 is 7. So for this part, we have negative 25, x to the sixth, and y to the seventh, plus. Okay, for the other one, we have 7 times 3, that's going to be 21, and then x to the sixth power, 3 plus 3 is 6, and y to the seventh power, 2 plus 5 is 7. And look at that. The bases are the same, x to the sixth and y to the seventh power. So in that case, we can just combine like terms. So negative 25 and positive 21 is going to give you negative 4. So negative 4, x to the seventh, x to the sixth, and then y to the seventh is going to be your answer. Okay, and that's it.